Good morning students, welcome my channel Bhuloks Mathematics. Last class I have already discussed about some problems related to integration by parts. Let us come and start some new problems related to integration by parts. Okay, let us come and start. Type. This is one question. Type. Write down. This is one question. E to the power ax sin bx plus c into dx. Here it is a constant and b is constant. So we know ILAD formula. I-L-A-P-E. I means inverse function, inverse trigonometric function, L logarithmic function, A which algebraic function, P trigonometric function, E exponential function. Exponential function comes second, trigonometric function comes first. So this is u and this is a v. So you choose this is u and this is a v. So you treat it as this is I. This is I. So applying the integration by parts. First means sin bx plus c. Integration of e to the power ax dx minus integration of derivative of first means sin bx plus c integration of e to the power ax into dx whole into dx. Okay, we know that integration of e to the power ax, the coefficient of x is divided. So write down sin bx plus c. The integration of e to the power ax, e to the power ax by a. The coefficient of x must be divided. So we know that derivative of sin bx plus c, that is integration of cos bx plus c into derivative of bx plus c. Derivative of bx plus c. Applying chain rule here. Integration of e to the power x. E to the power x by a into dx. Okay. So now sin bx plus c e to the power x by a minus integration of cos bx plus c, derivative of bx plus c, that is b is constant, that is outside, x derivative is 1, derivative of constant c is 0. So here it is a to the power ax by a into dx. So b by a is a constant that will coming outside. So sin, here it is dx plus c e to the power ax by a minus b by a constant that will coming outside of the integration. Again also applying the integration by parts. First cos bx plus c integration of e to the power ax dx minus integration of derivative of cos bx plus c integration of e to the power ax dx whole into dx. Okay, so now we get sin bx plus c e to the power ax by a minus b by a multiplied minus b by a cos bx plus c, again integration of e to the power x, that is e to the power x by a minus that is a plus b by a derivative of cos bx plus c, that is minus sin bx plus c into b derivative of dx plus c, that is b, applying chain rule. Here it is integration of e to the power x by a into dx. Okay, so now we get sin bx plus c e to the power ax by a into a, that is b by a square cos bx plus c. Here it is b by a, here it is also b by a, that is minus b square by a square integration of e to the power ax sin bx plus c whole into dx. This is also I is repeated here, you see, this is I, so this is also repeated I, so that will coming to that side. So write down I plus b square by a square into I b square by a square I. So you take LCM here, a square LCM. So e to the power x common, so a sin bx plus c minus b cos bx plus c. Okay, so here it is I common, we get I is taking common, so we get, when I is taking common, we get, taking LCM, a square plus b square by a square. Here we write e to the power ax a sin bx plus c minus b cos bx plus c divided by a square. This a square cancelled. So I becomes, I is equal to e to the power ax divided by a square plus b square whole into a sin bx plus c minus b cos bx plus c. So this is the answer. So you remember, this is also one formula. Write down, this is one formula. So write down the formula. Integration of e to the power ax sin bx plus c is into dx is equal to e to the power ax by a square plus b square whole into a sin bx plus c minus b cos bx plus c. This is the answer. The coefficient of x is a here, here it is b here. So applying, this is one formula you have to remember. So application, a formula को applied करिबा. How can you integrate some example? So write down one example. Integration of e to the power 3x sin 2x dx. How can you integrate it? A is 3 here. You see, A is 3. B is 2 here. B is 2 here. So applying that formula. So we get e to the power 3x divided by a square plus b square, 3 square plus 2 square whole into a sin, a means 3 sin 2x minus b, b means 2 cos 2x plus c. So 3 square 9 2 square 4. So the result will be e to the power 3x by, here it is 13 whole into 3 sine 2x minus 2 cos 2x plus c. Okay, so this is the application of this formula. Using this formula you can work out so many problems. Okay, so this is one question. So write down another type. Another type, write down. Question. Integration of 2x square plus 1 into e to the power x square dx. So this is very special problems. So whose derivative is this? Derivative is given. Whose derivative is this? So that is d dx of x into e to the power x square. Okay, so when you differentiating this, we get this. So derivative integration, they neutralizes to each other. So that is x e to the power x square plus c. Okay, so we know here it is a derivative. How to get the function? So that is the answer. You see here, d dx of x into e to the power x square. So derivative must be equal to this. So you know first derivative of second e to the power x square. E to the power x square d dx of x. So e to the power x square derivative, that is x e to the power x square, derivative of x square, that is 2x. So here it is e to the power x square, derivative of x is 1. So you take common e to the power x square, taking common, so 2x square plus 1. Okay, so derivative of this is here. So the function is like this. Derivative integration, they neutralizes to each other. We get the answer as like this. Very special problem, so you have to remember. Next, write down another question. Integration of x sine inverse x dx. How can we integrate? So there are two types of functions available. One is a inverse trigonometric functions, another is a algebraic functions. So inverse trigonometric function come first, algebraic function comes second. So apply the integration by parts. First, sine inverse x, integration of x dx minus derivative of first means sine inverse x, integration of x dx whole into dx. So integration of x dx, that is x square by 2. So sine inverse x, here it is s square by 2 minus derivative of sine inverse x, that is 1 upon root over of 1 minus x square. Integration of x dx, that is x square by 2 into dx. Okay, so here 1 by 2 is a constant that will be coming outside. So here we get s square by 2 sine inverse x. 1 by 2 is a constant. So I am writing like this, 1 by 2. So here it is minus, then will be coming to inter, minus x square. Here we add 1 and minus 1. Adding and subtracting 1 and minus 1. So we get 1 minus x square into dx. Adding 1 and subtracting 1. So this upon this minus this upon this. So separating, we get x square by 2 sine inverse x. Here it is 1 by 2. So this upon this, that will be integration of 1 minus x square into dx. Another is minus integration of dx by 1 minus x square. We know that s square minus x square integration. We know one formula is there. S square minus x square integration x by 2 s square minus x square plus s square by 2 sine inverse x by a plus c. So this is the formula. So applying this formula here, we get s square by 2. Here it is sine inverse x 1 by 2 whole into, applying this formula, x by 2 root over of 1 minus x square plus s square by 2. 1 by 2, here it is sine inverse x. So integration of 1 minus s square root over, that is also sine inverse x plus c. So after simplification, we get 1 by 2 sine inverse x minus sine inverse x. The result will be x by 2 sine inverse x plus 1 by 2. Here it is x by 2 root over of 1 minus x square. So after simplification, we get minus 1 by 2 sine inverse x plus c. Okay, so this is the answer. Okay, now I come to end my classes. Thank you to all for watching my videos. If you like my classes, please subscribe my channel and share my channel and like my channel.